So this is Hartley oscillator. Circuit diagram for the Hartley oscillator. Okay. See this circuit diagram. It consists of a transistor amplifier along with the tank circuit and the feedback circuit. Okay. Now the tank circuit consists of C, L1, L2. The L1 and L2 are to be tapped at the center. Okay. Here the RF choke provides the which decouples the AC mains so as which will not affect the output voltage which we are measuring across this terminals 2 you may call. These are the terminals 2. This is plus and this is minus. So V out is to be measured across this one. As we are not using here terminals 1 as the any device which is to be studied in the two-port network. So according to that one we are calling this one as a 2-2. Okay, so this is transistor Q. The emitter is having the resistance RA and CE. This is CE. Okay, the voltage divider arrangement is provided across the base of the transistor with R1 and R2. VCC is applied and the tank circuit and the feedback. Okay. Now the as the circuit is to be turned on, as the circuit is to be turned on, the capacitor gets charged. As the capacitor gets charged, it is discharged through the inductances L1 and L2, and the electrostatic energy which has been converted into the magnetostatic energy. Further, this magnetostatic energy, if suppose the upper plate is positively charged, lower plate is negatively charged, so that the magnetostatic energy is to be developed across the inductances L1 and L2, keeping the lines of force like this. Okay. Now this magnetostatic energy, magnetic field energy, is further collapsed because of the capacitor which is to be connected across this one, and this energy is being converted into the electrostatic energy. This is repeated again and again, so that the oscillations are set up in the tank circuit. These oscillations which are to be set up in the tank circuit. Now the voltage which appears across this one, the inductor L1, is the output voltage, whereas the voltage which appears across this L2, the voltage which has to be developed across the L2 is to be fed back. That is the feedback voltage VF. Okay. Now this one is to be fed. This voltage is out of a phase, 180 degree out of a phase as compared to the voltage which is to be developed across the inductor L1. So we will see this diagram that the one capacitor and the two inductors. Call this as L1, this as L2, so this is plus minus, and this is minus plus. So the voltage which is to be developed across this one is nothing but the output voltage V out, whereas the voltage which has to be developed across this one is nothing but the voltage which is fed back, that is the feedback voltage VF, okay, which is out of a phase as compared to the voltage across the L1. Now this voltage is fed through this transistor to the base of the transistor, and which appears in the amplified fan across the conductor circuit. That energy is to be supplied to the tank circuit to meet the losses. Okay, to meet the losses in the tank circuit. Again the process is to be repeated again and again, so that as we get the oscillations which are to be set up in this one of desired frequency, so that the frequency of that oscillation is to be given by f is equal to 1 upon 2 pi under root of L. Now we have L1 and L2, therefore the total inductance is LT into C. Hertz. Okay, this will be hertz. So this is the frequency of oscillation is to be given as f is equal to 1 upon 2 pi under root of LT into C. Whereas the total inductance L, as the inductances L1 and L2 are in series, is to be given as MV is equal to, this is L2 divided by L1. How we will see that? This is the feedback voltage Vf divided by the output voltage Vout. As the feedback voltage is to be given by the XL2, XL, that is XL1, okay, and the feedback voltage, this is XL2 feedback voltage, okay, XL2, and this is XL1. This reactance is directly proportional to the inductance of the inductor. Therefore, this comes to be L2 divided by L1. Okay, L2 divided by L1. Therefore, the feedback of action MV is given by L2 by L1. Okay, so this is about the Hartley oscillator. It consists of a tank circuit, a feedback network, a transistor. Okay, now the as the circuit is to be turned on, the oscillations are to be set up in this tank circuit. These oscillations which are to be set up in the tank circuit are in such a way that the voltage which is to be developed across the L1 is nothing but the output voltage, and the voltage which is to be developed across the L2 is nothing but the feedback voltage. This is to be fed through the capacitor C to the base of the transistor, which appears in the amplified form across the collector. Now here the RF choke that decouples the AC components, which will not affect the output of the device. Now whatever the voltage which is to develop across the L2, okay, that if it is off, if the oscillations which are to be developed, which are to be generated are of desired frequency, then the output is to be taken. If not, then again it is to be fed back, and again the procedure is to be repeated. The feedback should be properly phased. How we are going to properly phase the feedback? That is, 180-degree phase shift is to be just given by this tank circuit, whereas the another 180-degree phase shift is to be occurred across the transistor action, so that the total phase shift of 360 degrees are obtained, so that the energy which is to be supplied further is in phase to the oscillations which are to be generated in the tank circuit. Now, in this way, the output